children, welcome to AIMS India's online classes. Today from our science subject we are going to continue our lesson matter. Now yesterday we have learnt about the matter, how matter is formed and what are the different forms of matter. Okay children, and we also learnt about atom and molecules. Okay, today we will be continuing with the rest of the topic. So before that we'll be learning some extended information. Okay, learning, let me read it for you. The lightness or heaviness of a substance for a given volume is called density. Okay, so what is density? Density, you might have heard this word density. What is that? The lightness or the heaviness. Here we are talking about the for example the weight. If you suppose if it is light or if it is heavy. Okay, so this weight of a substance for a given volume is called density. Okay, and density depends on how closely the molecules are packed in a given substance. So, and density, it is going to depend on how closely the molecules are packed in a given substance. For example, a stone is denser than a block of wood because the particle in a stone are very closely packed. This is packed, children, compared to the block of wood. No, so the density of a stone is heavy when compared to the density of wood. Why? Because no, if you see, if you take a stone, if you take wood, children, of the same size, what happens? Stone is going to be very heavy than the wood. Why? Because the density of the stone is high, because here the particles in the stone are very closely packed when compared to the block of wood. No, so wood, you can break the wood also, but stone, no, you cannot break it that much easily. Why? Because the density is heavy and the particles here in the stone are very closely packed. So the density of any matter, it is going to depend on how closely the molecules are packed in a given substance. Okay children, and one more science in context is, have you ever wondered which is heavier? See, 1 kg of iron or 1 kg of cotton. We are talking about the density here again. So is 1 kg of iron is heavier or 1 kg of cotton is heavier? So you may say, but this is not true, as both weigh the same. Okay, most of them, or most of us, we may say that iron is going to be much weight, but children, both of them, like 1 kg of iron and 1 kg of cotton, both have got the same weight. No, same weight. So 1 kg of iron is maybe this much, but 1 kg of cotton is this much. Okay, 1 kg of cotton is this much. But here, this is light in weight, but iron is little heavy to carry, that's all. But the weight is the same. When you, for seeing, we feel that I mean cotton will be lighter, but in practical the both have got the same weight. Okay, and the difference is in the intermolecular space between the two. Why is the difference? Because the difference is in the intermolecular space, as we said, between one molecule and another molecule. You'll be having a space which we call it as intermolecular space, children. So this difference is because of that particular intermolecular space between the two. Okay, and the particles of iron are very closely packed, making the iron ball denser. The particles of cotton, on the other hand, are loosely packed, so it occupies more space but is less dense. Sorry, see, that's what I said. The particles of iron are closely packed. Okay, if you see 1 kg iron is this much only, but 1 kg of cotton is this much, because here this is denser when compared to cotton iron. Okay, but the particles of cotton, what happens? So they are loosely packed, so it occupies more space and it is less dense. Okay children, so this is how, so we can have or we can check the density of this matter. Clear children? So we'll be learning about heating and cooling of liquids. Okay, so what happens when we heat a liquid? What happens? So D is not there children here. So what happens when we heat a liquid? Let us know. When a liquid is heated, the molecules acquire energy and move faster. So when it is heated continuously, the molecules ultimately move so fast that they are no longer in contact with each other, and thus the liquid changes into gas. So have you seen children, when you put something like water and you heat the water on the stove, what happens after some time when the water starts getting heated and boiling, you'll be able to see more evaporation in the form of smoke. No, so not only water, any liquid, if you take milk or any other liquid, okay, when you heat it, you can see the evaporation. As it is heating more, the evaporation will be more. So the liquid form is changing into the gas. What happens when we are going to heat the matter? What happens? The liquid form is going to change into gas. Okay. So when a liquid is heated, the molecules acquire energy and move faster. So they are going to acquire, they are going to get more energy and they are going to move faster. So we have learned that we will be having molecules, no, in the matter, and these molecules, when they are heated, they are going to get more energy. So when you get more energy, what you do? You can work more fast, you can work more actively. No, same it happens here. So they are going to move fast, and when it is heated continuously, then the molecules ultimately move so fast that they are no longer in contact with each other. Okay, so when we are heating the liquid continuously, so it is getting more and more heated, then what happens? These molecules, they are going to move so fast because they get more energy. No, as we have learned that the molecules get energy when they are heated. When you are heating more, the energy also will be more. And when they get much energy, they are no longer, they are not going to contact each others. No, they are not going to contact each other. Now they are free. They are free, as we have learned that in the gas form, molecules are like free birds. So they are not going to get into contact with the other molecules. No. So then the liquid is going to change into gas. Clear children? This is what it happens when the matter is going to heated, that is any in liquid form is going to heated, and that liquid form is going to change as gas. Okay, now, and this process in which a liquid changes into gas is called evaporation. So this is what we call it as evaporation. What is it? The process in which a liquid is going to change into gas is called evaporation. And evaporation causes when wet clothes uh, are to dry and the water in them is disappearing. Water in them is to disappear. Okay, so even if you observe children, when you just dry the wet cloths, no, you try to dry the wet cloths in the sun, okay, in the sunlight, what happens after some time? All that water is absorbed by the heat of the sun. Okay, and they are going to dry. The cloths are going to dry completely without any water. So what happened to the water? What happened to the water in the cloth? In that cloth? So they have disappeared. They have changed into the gaseous form. No, they have changed as water vapor and they have disappeared. No. So this is nothing but evaporation. Okay, and so water in the cloth changes from the liquid state to the gaseous state. So children, remember that. So whenever you heat a liquid, then that liquid is going to change to gas. Okay, so when you heat liquid state, then it is going to change to gaseous state. Clear, children? Now we'll see what happens when we cool a liquid. So this is opposite. So when you cool, what happens? Any liquid. So when a liquid is cooled, the molecules slow down, and when the cooling is continued, the molecules come close together and rearrange themselves to become a solid. See children, so when liquid is cooled, what happens? Suppose if you are having a glass of water, and you'll just keep that glass of water in the fridge, that too in the freezer, that is in the frozen area. Okay, so then what happens? This water which is in liquid form is going to become as ice. It becomes, no, it changes into solid form. Clear? Why? Because when a liquid is cooled, okay, the molecules which are there in that particular liquid, they are going to slow down. So when they get slow down, so they will not be having the energy to move. No. So and when the cooling is continued, when still we are increasing the cooling levels, then the molecules, they come close together and rearrange themselves to become a solid. So when it is more cool, then the molecules are going to come close together and they are going to form as a solid. So normally children, in winters, if you see, a very simple example I am giving you. So in winters, when we feel very cold, what happens? We'll just take take all our body parts, like we'll take our hands, we'll take our legs very close to our body. No, we'll wear sweaters and we'll just sit very close, like in a tight position. No, you'll just grab your legs, hands very close to your body. No, why? Because of the coldness in the climate. No, so here also what happens, if there is much coldness, then when the liquid is going to get cooled, the molecules also, they are going to slow down and they are going to come close together and they are going to rearrange themselves to form a solid state. Okay, and this process in which a liquid changes into a solid is called freezing. Okay, so this process where a liquid is going to change into a solid, what is it called as? It is called as freezing. No, so you just remember the example what I have given, that. So when you feel cold, what you do? You'll take your body parts very close to your body. No, body parts in the sense, especially hands and legs. No, like that. Okay, and the rate of freezing is different for different liquids. Here the rate of freezing, like the frequency of freezing, it is different for different type of liquids. Okay children, see here. And now this is the picture, like where it is showing, like when liquid is cooling, what is going to happen, and when liquid is heated, what is going to happen. So what we have learned, that when the liquid is getting cooling, it is going to become a solid. No, so these molecules are rearranging themselves because they are slowed down. No, their activity is very slow and they are going to rearrange themselves to form a solid state. Again, when the liquid is getting heated, so what happens? They get more energy. Their energy levels are increasing and they are going to form as a gas. They are not, they are losing contact with the other molecules and they are very free and are going to change into a gaseous form. Clear, children? Okay. Now what about heating and cooling of solids? Until now we have learnt about the liquids. Now we learn about the solids. What happens here? When solids are heated, the molecules start to vibrate faster. On further heating, the particles move around and gradually turn into liquid. So here also. So when the solids are heated, what happens? The molecules in the solids, they start to vibrate faster. So whenever they get heated, the molecules, children, so their movement will be very fast. Okay, so again if you are going to heat the solid more, then the particles are going to move around and this solid state is going to become a liquid state. So for example, if you have kept in you have kept an ice cube, no, you have kept a glass of water into the fridge in the frozen area, what happened? It turned into ice. No, so that was into solid state. Now just remove that ice from the fridge and keep it on the table or somewhere under the room temperature. What happens now? That ice again is going to melt. Again it is going to become water, which is in liquid state. No, so this what happens when it is getting heated, because now it is facing the room temperature. No, heating in the sense it's not that we have to take it and we have to put it on the stove and heat it. Heating in the sense when it is exposed to the temperature. Okay, clear, children? Yes, so the particles, they are going to move around and they are going to turn into liquid when they are getting heated. Okay, and this process in which a solid changes into liquid is called as melting. What do you call this process? Where a solid is going to change into liquid, and this process is nothing but melting. Clear, children? So not all substances undergo melting at normal conditions. Okay, and some solid substances may undergo certain other changes on heating. For example, paper burns when it is heated. However, most solids expand on heating. So what is that? So not all substances. So we have learned that all the substances on this planet Earth and in the universe have got matter. But when you heat a solid substance, not all substances are going to melt. They do not undergo melting at normal conditions. Okay, some solid substances, for example, like paper is also one substance, but when you burn a paper, what happens? It is going to burn. No, paper is going to burn when you heat a paper. It is not going to become liquid. No, children. So only some exceptional cases, only some are going to expand on heating and some are going to change into different form. Okay, children. So however, most solids expand on heating, but most of the solids, even if you plastic also, if you see, children, plastic also, if you just heat the plastic, so it is not going to become water, but still it is going to expand. No, the shape of that particular object is going to change. No, you can see some liquid type of gummy type of substance. Even iron, if you see, gold you see, silver you see, aluminium, any metal also, if you heat it, it is going to change its shape. It is going to expand. Clear, children? This process is nothing but melting. Okay, so here is one more example for you. Let us just read that first. Safina has a metal ball and a ring. Okay, Safina is the name of a girl who is having a metal ball and a ring. Before heating the metal ball, the ball could pass through the ring. Then she heated the metal ball over a flame until it got very hot. She tries to pass the heated metal ball through the ring and found that the ball could not pass through the ring. So what this girl do? She was having a metal ball, okay, and a ring. Before heating the metal ball, so she wanted to heat the metal ball, but before heating it, the ball was able to pass through the ring. See here. Here is the ball and here is the ring. So before heating, what happened? It was able to pass through this ring. But after heating this ball, what happened? The ball shape has been expanded because it was a metal ball. And now it is not able to enter into this ring. Okay, children, why? Because this substance has been expanded. No, the shape has been, the size has been expanded, which is not able to fit in the ring as it was fitting before heating. Clear? So this is the difference. Okay, like how you can see, like what happens to a solid form when it is going to heat it. So this is nothing but melting. Okay, children. So here are some questions for you. What would Safina conclude from this experiment? And how can Safina pass the metal ball through the ring once again? Okay, will you able to do this? Yes. So what happens is, in the above example, when the ball is heated, the molecules move further apart, causing the size of the ball to increase. So this is called expansion. Okay, so as we have learnt about this melting, no, when we talked about this liquid solid into liquid, then that was melting. Again here, when this metal ball was heated, children, the molecules they moved further apart. They just moved apart. They were disconnected with the other molecules. So which was able to were able to expand the ball size, where the ball size was expanded. Okay, and this is nothing but expansion. We call this as expansion. Okay, and when the ball is cooled, what happened? The movement of molecules slowed down and they come closer to each other. This is called as contraction. Okay, so when the ball is cooled, what happens? The movement of molecules, again their activity is going to slow down and they are going to come closer to each other, and this is nothing but contraction. Clear, children? So you have to remember these two words, that is expansion and contraction. What is expansion? When some substance is heated, especially when here we are talking about the metal ball, so the molecules are going to move further apart, causing the size of the ball to increase. No, so any substance there to increase, that is called as expansion. And again, when the ball is cooled, the movement of molecules is going to slow down and they are going to come close to each other, and this is called as contraction. Okay, children, understood? Yes. Now, so this is what we have learned in today's session. So hope you have understood this, and we'll be continuing in tomorrow's topic. Until then, take care and goodbye.
Visit our website www.aimstoday.in For other information regarding online classes, quizzes, live worksheets, DIY activities, English classes and coding. Thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates.